Day 5. You need to know what it is, not how to do it. And sort of how it affects things, too. So the power of a test. This is the definition the book gives. Is the probability that the test will find convincing evidence for the alternative, for ha, which is to reject the null. When a specific alternative value of the parameter is true. Bless you. So the parameters usually that we're looking at, p, mu, sometimes sigma, right? So let me put this into layman's terms for you. It's the probability that you've made a type 2 error. That's really what this is. Power is the probability. It's actually the inverse probability of a type 2 error. You'll see what I mean by inverse here in just a second. That's the gist of power. So it's inverse in that as power increases, probability decreases. So because of that, the calculation, if you know power equals 1 minus the probability that a type 2 error occurs, or the probability of a type 2 equals 1 minus power. Oops, I run out of space there. Sorry. 1 minus the power. So it's an inverse relationship. If your power is high, your probability of type 2 error is low. If your power is low, then your probability of a type 2 error is high. How to increase power? There are 3 ways. Increase the sample size. So we've talked about increasing the sample size, doing many things over this year so far. If you increase the sample size, what you do is you decrease that likelihood of a type 2 error. And think of it this way. So the other day when we talked about type 1 and type 2 errors, I said that if you were within about 0.5% on one side or the other, whichever was type 1 or type 2, you probably needed to make mention of that possible error, right? But that's just my general rule. But if you have a really large sample size, then probably that 0.5 is way too big. If you say you're sampling 5,000 people, then maybe you think maybe it's 0.1. I don't know exactly. I'm just kind of theorizing here. But as your sample size increases, that idea of how far out you have to go to get to a type 1 or type 2 error possibility shrinks, just like the standard deviation shrinks when you increase your sample size. So I'm going to stick to my statement. If you're within 0.5%, make a comment about a type 1 or type 2. But if you have a really large sample size, 0.5% is not in any danger at all. But what is that? Where is that boundary at that point? I don't know. So I'm sticking to my 0.5%, but understand that that's changing based on the sample size. The other thing is to increase alpha. You're going to go from a 1% to a 5%? Yeah, that'll change it. But you can't always do that. If you're trying to take somebody to court, and you've got a low power, so a high probability of a type 2 error, and you increase your sample size, I'm sorry, if you increase your alpha, well, now you're no longer within the boundaries that the court would allow. So that could be a problem. So that leads you back to increasing the sample size, perhaps. And the last one is when the ho and ha, the null and the alternative hypothesis, parameter values, are farther apart. So maybe you change your alternative hypothesis and you run the test again with a slightly different change, a slightly different alternative. So those are the things to know about power. We'll look at a couple problems. There's one more thing. Notice that this power thing is only talking about the probability of a type 2 error, which is all that it handles. What about the probability of a type 1 error? The probability of a type 1 error is just alpha. I'm going to just fill this in at the bottom of the page here. The probability of a type 1 error equals alpha. So if your alpha is 5%, the probability of making a type 1 error is 5%. It's whatever the area of the curve is. The reason power comes into play is how far away you get in your type 2. If you're a fail to reject, how far away from that which I should have rejected do you get before you really have no concern for an error at all. Alright? Everybody okay with that? Let's look at a graphic. Unfortunately, I can't put that on my video here, so I'm going to end that. But let's look at